if you interchange the rows and columns of any determinant, the value is unaltered. The value will be the same. If any one of the two rows or any one of the two columns are identical in the determinant, then its value will become 0. If any one of the row or any one of the column inside the determinant is a sum of any two numbers, then we can separate it and write it in the form of the sum of two determinants. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In today's session, we will be discussing about the determinants and the properties of determinants. What do you mean by determinants? So, determinants is only for a square matrices. It gives a real value for the square matrix associated. So, it is nothing but a real number. Hence, we can call determinant as a function from the set of matrices to the set of real numbers. That is, you can call the domain as the set of the matrices, especially the square matrices, and the range as the set of real number, because the solution of the square matrix will be a real number. So, hence we can call it as a determinants of a square matrix. It is only for a square matrices. Hence, every square matrix is associated with a real number and its value is called as determinant. Hence, if a matrix is written in the form of a 1, 2, 3, 4, we denote the determinants by the bars like this 1, 2, 3, 4. So, this is the square matrix and this is the determinant of the square matrix 1, 2, 3, 4. Hence, we call determinant is defined as a mapping or a function from the set of all square matrices to the set of all real number. So, you can call the domain as the set of all square matrices and the range will lie in the set of all real numbers. Next. So, here are examples how we denote any determinants of a square matrix and how we can evaluate a determinant. Suppose we have any square matrix A, B, C, D. Let A be a square matrix A, B, C, D. Then determinant of a matrix A is given by AD minus CB. So, this is the determinant of a square matrix of order 2 cross 2. So, this is a square matrix of order 2 cross 2. If a matrix is of the order 2 cross 2, then the determinant of the matrix is given by AD minus CB. So, if you apply the rule here, so what is the determinant of this matrix? It is 1 into 8 minus 5 into 3. So, 1 into minus 8 is minus 8 minus 5 into 3 is 15. So, minus 8 minus 15 will give you the value minus 23. So, this is the real value. Hence, determinant of a matrix, that is especially square matrix, will give you the value which is a real number. Now, let us see how we can evaluate this determinant. So, this is 0 into minus 5, which is 0, minus, you can take like this, minus 2 into 3, that is minus 6. So, minus of minus 6 is plus 6. So, this is the value of the given determinant. Now, here we have evaluate the determinant. So, it is a square matrix of order 3 cross 3. So, how to evaluate the determinant of a square matrix of order 3 cross 3? That is writing out its determinant, neglecting the element which is in a particular row or column. So, how we can evaluate the value of the determinant? Before that, we should remember the sign of the values of the elements, that is positive, negative, positive, minus, plus, minus, plus minus plus. You should remember this rule for all to evaluate the determinant. So we will consider any one of the row or any one of the column and we will multiply using the cofactors. So that is, so here how to evaluate the determinant. The determinant value also symbolized in the form of a delta. So how I will calculate the determinant? So here I am using the first row. That is, first I will take 3. So 3 into, leave the row and column of 3. So write only the remaining elements and write it in the form of a determinants. 2 minus 2, 4, 5. So if you are taking the first row, then the sign should be plus minus plus. So here it is plus. Next I have to take minus 0 because the second element is 0 here. So leave the column, leave the row of 0. So what are the numbers remaining now? 1, 4, minus 3, 5. Write it in the form of a determinant. 1, 4, minus 3, 5. Next we need to take a positive plus minus 1. The last row number is minus 1. So leave the row and column containing minus 1. Write only the remaining number. What are the remaining number we have? 1, 2, minus 3, minus 2. So it is 1, 2, minus 3, minus 2. Now evaluate as it is. You have evaluated the determinant of order 2 cross 2. So therefore here this is 3 into 2 5s are 10 minus 2 into 4 is minus 8. Minus 0 into anything will become 0. So I'll write it as 0. Plus int here we have minus 1. 1 into minus 2 is minus 2. Minus 3 into 2 is minus 6, which becomes minus of minus 6. Because it is 1 into minus 8, minus of 5 3s are. So you have to take the negative AD minus CB. So therefore it is 1 minus 2, minus of minus 3 into 2 is minus 6. So therefore 10 minus of minus 8 is 18. 18 into 3 is equal to 54. Next the second term is 0. So we can leave. Minus 2, minus of minus 6 becomes plus 6. So it is 4. 4 into minus 1, minus 4. 54 minus 4 is 50. So like this, you can evaluate the determinant value. So this is in terms of row we have calculated. Like this, we can take any row, any column to calculate the value of the determinant. So whatever the row you take, you should leave the rows and column containing that number and write only the remaining in the form of a determinant, and remember how to write the sign especially to evaluate any determinant. So for the same question, now I can take using the column also. So remember the sign plus minus plus minus plus minus plus minus plus. So let me take the column wise determinant. So the value of delta here is equal to 3. So first number is 3. So leave the row, leave the column containing 3. So if you leave it, you should cancel these terms and you have only numbers 2, minus 2, 4, 5. Write it in the form of a determinant. 2, minus 2, 4, 5. So this is done. So next I have to take 1, but 1 you have to take it as minus 1. So let me take it as minus 1. Now leave the row containing 1 and column. So you are deleting the row and deleting the column containing 1. Write only the elements which are present in the form of the determinant. 0, minus 1, minus 2, minus 5. So this is done. Next we need to take the last term, but you have positive sign here. So write plus, but here it is minus 3. So leave the row and column containing minus 3. Write only the remaining terms. What are the remaining terms? 0, minus 1, 2, 4. Now evaluate the determinant in the form of 2 cross 2 matrix you have done. So it is 3 into 10 minus of minus 8. Next minus 1, it is 0. Minus 2 into minus 1 is 1. So you have minus 2 into minus 1 is 1, 2. So this is done. Next we have plus minus 3 here. So 0 minus 2 into minus 2 is minus of minus 2. So now it is 3 into 18. Next, minus 1 minus 2 becomes plus 2. Minus 3 minus of minus 2 is plus 2. So minus 6 here. So 54 plus 2 minus 6, which is equal to 56 minus 6, which is equal to 50. So you will get the same value, that is 50. Previously, we have calculated using the row pattern. Now we have done in column wise. So therefore, the value of the determinant can be calculated either taking any row or any columns from the square matrix of order 3 cross 3. Hence, the value, however you calculate by taking the first row, you can also calculate using second row, but the sign changes in the pattern, minus plus minus. First minus, second plus, then minus. Or last column, or the last row, or the middle column. So, however you calculate with the help of sign and writing the remaining elements in the form of a determinant, the value of the determinant will be same. In general, we always use rows to calculate determinants. That is, you can write it in the form of 3 into 2, 4, minus 2, 5. Next, minus 0. So, leave the row column containing 0, 1, 4, minus 3, 5. And last, plus minus 1. Leave the row and column containing minus 1. Write the remaining in the form of a determinant. So, this is how you are going to write. Solving this, you will get the value as 50. So, and the value, if you say this as a matrix A, so we write det A in the form like this or delta. So, these are the symbol used to determine the value of any determinant. So, we have learnt how to write the determinant value for 2 cross 2 matrices as well as 3 cross 3 matrices. Now, here we have few questions. Solve for x, where x 4, 4x is equal to 0. They have given the value of the determinant is 0. Since this is a 2 cross 2 matrix, it is very easy. That is, determinant is x into x, x square minus 4 4s are 16 is equal to 0. So, we have x square is equal to 16, x is equal to plus or minus 4. Since the value is in the set of real numbers, it may be plus or minus 4. Next, we are taking same type of question. Find x if x 3, 12x is equal to 0. So, here I can write the value of the determinant x square minus 36 is equal to 0. X square is equal to 36, x is equal to plus or minus 6. So, this is how we can calculate the unknown variable with the help of the given number. So, next we come across the properties of determinants. We have many properties of determinants which helps us to evaluate the given determinant. What does property number 1 says? The value of the determinant remains the same if the rows and columns are interchanged. So, let me take a determinant delta is equal to A1, A2, A3, B1, B2, B3, C1, C2, C3. So, if you write this, then delta will be in the form of A1 into, so this is the leaving the column and row, you will get B2 C3 minus C2 B3. Next you have minus A2. So, leave the column and row containing A2, you have B1 B3 C1 C3. So, how you can get it as determinant? B1 into C3 minus C1 into B3. Similarly, the last A3, you will get it as leaving the column and row B1, B2, C1, C2, B1, C2 minus C1, B2. So, B1, C2 minus C1, B2. So, this is the value of the delta you will get. So, let us see what happens for delta 1. So, delta 1 will be A1, B2, C3 minus A1, C2, B3 minus A2 B1 C3 minus into minus plus A2 C1 B3 plus A3 B1 C2 minus A3 C1 B2. So let me take this as equation 1. So this is delta 1 I am getting. Let's interchange any one of the row or any one of the column. So let me interchange only the row. So now let me take the determinant delta 2. So delta 2 is equal to, so they have asked us to change the rows into columns. So we have A1, A2, A3. I'll write it as A1, A2, A3, B1, B2, B3, C1, C2, C3. So the now rows and columns are interchanged. So let me multiply. So if I take delta 2, so let me see what happens. So A1 becomes B2 C3 minus, again I can take A1 B3 C2. Next minus B1. So we have B1, leave the row, A2 C3 once, next A3 C2. So B1 A2 C3 plus B1 A3 C2. Next we have C1 plus C1 A2 B3 minus C1 A3 B2. So you can clearly see you have A1 B2 C3, A1 C2 B3. Next you have A2 B1 C3. Next A2 C1 B3. Next you have A3 B1 C2, A3 C1 B2. So you have all the elements which are positive numbers as well as negative numbers which are one and the same. So from equation 1 and 2, you can clearly say delta 2 and delta 1 are same. So that is, if you interchange the rows and columns of any determinant, the value is unaltered. The value will be the same. So the next property, determinant changes its signs when any two of its rows or column interchanges. So suppose let me take delta 1 in the form of A1, A2, A3, B1, B2, B3, C1, C2, C3. So if I calculate delta 1 and write the value directly, I will get A1, B2, C3 minus A1, C2, B3. Next I have minus A2. So leave the row and column. First B1, C3 plus A2. Next I have C1, B3. Next plus A3 B1 C2 minus A3 C1 B2. So this is delta 1. Now let me take delta 2. So here I will change any of the two rows. So let me interchange the first and second row. I'll write B1, B2, B3 first, A1, A2, A3 second, C1, C2, C3 third. Let me calculate delta 2. So delta 2 is B1 A2 C3 minus B1 C2 A3. Next I have minus B2 A1 C3 plus B2 C1 A3. Next plus B3. So leave B3 column here. I have these two factors. Once I'll get A1 into C2 along with B3 minus B3 C1 A2. So here let me take minus as a common factor. If you take minus as a common factor, here you will get minus B1 A2 C3 plus B1 C2 A3 plus B2 A1 C3 minus B2 C1 A3 minus B3 A1 C2 plus B3 C1 A2. So clearly this is the value which you have in delta 1. So here you have delta 2 is equal to minus of delta 1. So that's what the property says. The value of the determinant is same, but only thing is the sign changes here. Now, next example, the value of the determinant is 0 if any two of its rows or columns are identical. For example, let me explain this through with an example. So, we have 1, 2, 3, 2, 2, 1, 2, 2, 1. So, this is the value of the determinant I need to calculate. Let me see what happens here. So, let me take it as delta. So, here I have 1 into 2 ones are 2 minus 2. So, that is 2 minus 2. Next, minus 2. So, leave the row and column here. 2 ones are 2 minus 2 again. Next, the last one plus 3. Leave the row and column. 2 2s are 4 minus 4. So, clearly the value is 0 here, 0 here, 0 here. The determinant value is 0. So, that's why it says that when here we have two rows which are identical, that is two rows contain the same element 2 2 1 2 2 1. If any one of the two rows or any one of the two columns are identical in the determinant, then its value will become 0. So, wherever you find the value in the form like 1 1 1, x y z, x y z, calculate the value of the determinant. Directly you can write the value of 0 because here two rows are identical. So, using the property 3, we can write the value of the determinant is 0 whenever any two rows or any two columns are identical. Next, if in a determinant the elements of any row are multiplied by the same scalar, say k, then the value of the new determinant is k times the given determinant. So, let me show through an example. Let me take determinant A is equal to 3, 6, 9, 1, 0, minus 1, 2, 1, 3. So, clearly you can see the first row is a multiple of 3. First, let us find out the determinant A. What happens to the determinant A? Determinant A is 3 into 0, 3 is a 0, minus 1 into minus 1, minus 1. Minus 6, 1, 3 is a 3, minus of minus 2. Next, plus 9. 9 is again 1 ones are minus 0, 1 minus 0. So, when you calculate it is minus of minus 1, 3. Next, you have plus 2, 5, 6 5s are 30. Next, plus 9. So, determinant A is equal to minus 18. Now, so this is what the determinant A, the value of the determinant A is minus 18. Now, here what I will do, I will take 3 outside. If I take 3 outside, here delta A, if I take 3 as a common factor from any row, then it becomes 3 ones are, 3 twos are, 3 threes are. So, 1, 0, minus 1, next 2, 1, 3. So, here you can again calculate the determinant. So, you will get 3, you have outside, use only the brick bracket. So, 1. So, same thing. So, here whatever you will solve, we will get it as 1. Next, you have 2 there. So, it is minus 2 into, so 5 you will get. Next, you have the last number as 3 plus 3, 1 minus 0. So, when you solve this, it is here you will get it as minus 6, which is equal to minus 18 again. So, therefore, the value of the determinant is same as the product of the scalar with its determinant. Hence, I can write in general, if delta 1 is any product of KA1, KA2, KA3, B1, B2, B3, C1, C2, C3, then I can write delta 2 as K into A1, A2, A3, B1, B2, B3, C1, C2, C3. So, that is delta 2 can be written as K into delta 1, because by taking K as common factor from any row. So you can take common factor from each row and each column whenever you are doing the determinant. But when in case of a matrix multiplication, when you are multiplying any scalar quantity to matrix, you have to multiply k to all the elements inside the matrix. But in case of determinant, if you have any scalar quantity, that means the value is multiplied to any one of the row or any one of the column. Next property, if each element of any row or any column of the determinant is the sum of two terms, then the determinant can be expressed as the sum of two determinants. Suppose we have a determinant in the form of x plus a1, y plus a2, z plus a3. And this is b1, b2, b3, c1, c2, c3. If in case we have any algebraic expression in the form of like this, then we can write the separate determinant as x, y, z, b1, b2, b3, c1, c2, c3 plus a1, a2, a3, b1, b2, b3, c1, c2, c3. So this is how we can separate the values inside the determinant. If any one of the row or any one of the column inside the determinant is a sum of any two numbers, then we can separate it and write it in the form of the sum of two determinants. So next property, property 6, if each element of a row or column is multiplied by a scalar and added to the corresponding elements of any other row or column, then the value of the determinant is unaltered. Let me take the delta is equal to a1, a2, a3, b1, b2, b3, c1, c2, c3. So they have said you have to multiply a scalar to any one of the row and you should add it to the any other row. So let me multiply k to the second row and let me add it to the first one. So then it becomes, so kb1 plus a1. So that is a1 plus kb1, a2 plus kb2, a3 plus kb3. So like this, multiply k to this row and add it to the first row. You can also add it to the last row. So any one of the row you can take. So similarly, if you are multiplying any scalar to any column, then you add it to any other column. So then what happens? They are saying the value of the determinant is unaltered. Let's verify this. So let me write the remaining. The first element I have written. The second set of elements is b1, b2, b3, c1, c2, c3. So what does property 5 says? The sum of elements can be written as a sum of determinants. So using that property here, I'll write this as a1, b1, c1, a2, b2, c2, a3, b3, c3. Let me take this as delta 1 instead delta. And the second row can be written as kb1, b1, c1, kb2, b2, c2, kb3, b3, c3. So the first one can be written as delta itself because it is a1, b1, c1, a2, b2, c3, a3, b3, c3, which can be written as delta. The second one, if you take k as a common factor, it will be in the form of b1, b2, b3, b1, b2, b3, c1, c2, c3. We know that if two rows are identical, the value will become 0. So therefore, k into 0 becomes 0. So we will get delta 1 is equal to delta. So that's what the property is saying. If you are multiplying any scalar and adding it to any other row of the determinant, the value of the determinant will never change. Next, if all the elements in a row of a column or determinants is zeros, then the value of the determinant is 0. So consider any row. So let me take a1, b1, c1, a2, b2, c2, 0, 0, 0. So this is the determinant. If any one of the row or any one of the column of the determinant is 0, then the value of the determinant itself is 0. Because we can write the determinant considering any one of the row or any one of the column. So if I take the third column in the form of plus minus plus and writing any other element, the value itself becomes 0. Next, if all the elements on any one side of both sides of principal diagonals are 0, then the value of the determinant is equal to the product of the elements in the principal diagonal. So suppose if you have a delta in the form of A 0 0 0 B 0 0 0 C. So if both element or both side of the principal diagonal elements are 0, then delta is equal to A into B into C. Because when you express this, this is A into BC minus 0, the second one is 0, the third one is 0. So when you add or expand the value of the determinant, you will get only one corresponding value along with A, that is BC. So A into B into C you will get. Or if it is in the form of A is equal to A1, A2, A3, 0, B1, B2, 0, 0, C1. Then since one side of the diagonal is also 0, the value is only equal to A1, B1, C1. So that is what the property says. We can also verify this with the example. So wherever you find the elements upside or down the principal diagonals are 0, or one side you have an elements, the other side the elements are 0, you can clearly write the delta as a product of the principal diagonal elements. So since the condition is one side or both side, if you find the elements either on the both sides or 0 or any one of the side under the principal diagonals or 0, you can write the value as A into B into C. That is the product of principal diagonal elements. Hope you understood how to expand to find the value of the determinant and all the properties related to determinant. We'll take the problems in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.